Today we are going to learn about using Logger Pro in conjunction with transducers to determine the spring rate for a single degree of freedom system. We will do this using two methods, static and dynamic. This video will focus on the experimental setup, while the concepts will be covered in more detail in the lab background and the pre-lab lecture. So, to begin, we will discuss the equipment that you will be using in this week's lab. We'll be using an extension spring, a lab stand, two metal rods, a force gauge, and a motion detector, masses, a basket, a ruler, a Lab Pro unit, and a laptop. And it will look like what you see here when it's assembled properly. When statically determining the spring rate, we need to measure the free length of the spring. Recall that the free length is the overall length of the spring before the force is applied. So, remember not to include the length of the hooks that are on the end of the spring in your measurement. And all you have to do is attach the spring to the hook on the force gauge. Now you need to pull downward on the spring to deflect it to a new position. And make sure that you stretch the spring more than 3 centimeters, but less than 9 centimeters. This ensures that you will not plastically deform the spring. Also be sure to record the change in the length of the spring and not the length of the stretched spring overall. Next, we will use both the force gauge and the motion detector in order to find the dynamic spring rate of the system. You will need to choose what amount of mass is appropriate for your setup in order to ensure that the motion remains in range of what the motion detector can sense. This range will be at least 1 foot away from the motion detector. When you pull and then release the basket, try to ensure that you have as little side-to-side swing as possible for better results. So this up and down motion instead of back and forth. And then in order to record that data, all you have to do is hit the collect button in the Logger Pro software. Once your data appears, look for any flat spots on the top and bottom of the displacement graph, like you can see we have right here. If there are flat spots, that indicates that your basket went beyond the range of the motion detector, and you must alter your setup by either changing the mass or relocating either the hanging rod or where the motion detector is sitting. And you need to repeat this step until you have eliminated all of these flat spots. You also need to look for discontinuities in your data, like you can see here. This could indicate that the sampling rate is too low due to something called aliasing, which we will cover in detail in the pre-lab lecture. For now, just know that increasing the sampling rate will fix this issue. To do that, we go under Experiment, and then to Data Collection.